Okay, viewers, welcome back to the last segment of the fourth lecture. So, in the last segment, in the second segment, we discussed how we can describe the facts using a diagram, and there were certain conditions associated with the fact that the sources should match and so should the targets, but the lengths of the paths could be different. Now, using a dummy variable, we can convert these facts into English too. All right. Let me show how to do that. I want to keep this diagram for the fact. Okay, so using a dummy variable, dummy variable x, one can convert a fact into English too. So there is an algorithm for doing that. I'll explain the algorithm. The fact, so we write that the fact P is equivalent to Q. From this figure, there are two paths. Path P is equivalent to path Q, and this can be Englishified. So this is a weird word, Englishified, that we encounter in the textbook. Englishified meaning that this diagrammatic notion is converted into English language, and this is what we mean by Englishified, as follows. Okay? This is what we are going to do. So this may not make sense at this moment, but when I give you specific examples, you will understand what these things mean. Okay? So given x, comma, s, right? X is the dummy variable that we are considering, and s is the source of both the paths. Okay? Given x, comma, s, comma, consider the following. We know that x is s. I know none of these make sense to you, but no, keep patience, you will understand what they really mean, okay? And I'm not going to explain anything because nothing makes sense here. So I'm going to write down these things and provide you with an example, and then you will understand what they stand for. Okay? So, then we come to the next sentence, which F1 is this first arrow, F1 and A1 is the second object here, F1, A1, without a comma in between, okay? There is no comma here. You just write A1 within inverted commas next to F1. Then you could place a comma here, which F2 within inverted comma, A2 within inverted comma, which F3 dot 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 f m minus 1 a m minus 1, then we put a comma which f m t, okay, then you write in a different sentence, not a different sentence, then you write it on in a different line, that we'll call px. Okay. A full stop. When you start a new sentence, we also know that you repeat the same thing with the G2 things, the G aspects. The aspects denoted by G1, G2 and G3, the same thing. You repeat with G1, G2, G3 and so on. We also know that X is S. Again, the same thing that we have done here. Where is that? We know that X is S. So we are doing the same here. X is S, which so I think I can erase this diagram now. We don't need it anymore. I need more space here because I need to I need to put down the example as well without erasing this part so that we can compare which G1, B1, which G2, B2. Notice that they are exactly the same. I just replace F1s, F1, F2, etc. with G1, G2, etc. and the relevant objects A1, A2, etc. with B1, B2, etc. Okay, which G2, B2, comma, which G3, and after G3 after F3 we had 3 dots. We put 3 dots. Then you write G n minus 1 then you write b n minus 1 comma which Gn we had FMT, now we have GNT that will call QX. Alright? Then we put a full stop. Then we write fact with an underline and say that whenever X is S, will have Px is equal to Qx. Alright. This is the English version of the fact. What we expressed using the diagrams before, okay? Okay. Now, let me give you an example. I draw a diagram and I erase this thing from here. Okay, and I draw a diagram on the, where do I draw the diagram? Let me try to draw it here. So this is the diagram that I'm going to use now. A person, we have already discussed it. I don't remember it. Perhaps not. So a person has an address, and this address is in a city. Okay? And that person lives in a city. So this is the diagram, the Olog under consideration. So this is an Olog. How do we Englishify this Olog? Well, this Olog represents a fact, because you see that starts from the source. So this path corresponds to the source, a person, and the target, a city, and this path corresponds to the same source, a person, and the same target, a city. Okay? So it fulfills all the conditions for having a fact, and we need to establish the path equivalences. This path is equivalent to this path. And how do we Englishify this equivalence of paths? Now we will see, okay, using this algorithm. Okay. So it means that we need to establish, but by means of English sentences, we need to establish the commutativity of this diagram. Okay? And how do we do that? Given x. So you see that we are repeating the same thing here. It's a generalized version with the dummy index x. Now we are translating everything here in terms of this example. Okay? So given x, then we are supposed to put a comma here and then write down the source here. What is the source here? A person. So given x, comma, a person, right, comma, we have considered the following. Consider the following. Right? We know that x is the source. X is, what was the source? A person. So we know that x is a person. Then, but we have a comma. Alright. Then which F1. What is F1? See that? For this path, this is F1, this is F2, and for this path, there is only one G here, so this is G1. There is no G2, and so this path has length 1, and this path has length 2. So there is only one G, whereas for the first path, we have two Fs. Okay? So we are considering the first path here, which F1, meaning which has which F1, A1. This is A0, this is A1, this is A2. So which F1, A1, which has an address, comma, again comma, which F2, A2, which is in a city, is F2, and A2 is a city, which is in a city, then that will call EX, right? So we are done with the first part. We put a full stop. Now we start from here. We also know that again X is a person. Now we are considering the other path, okay, which we denoted by Q in the previous diagram. This is path P and this is path Q. So we also know that X is the person, since we have it written down here. We also know that X is S and S is the person, comma, which G1 is lives in, which G1 B1 is a city, which lives in a city. Okay. So this ends here because we don't have to go all the way up to Gn because n is 1, so it ends here. Okay. So we go right there. That will call QX. It's in a city. That will call QX. Alright. So let me erase this thing. A few more sentences from here because we're running out of spaces. Fact. Underline fact here. Whenever X is a person, we'll have Px is equal to Qx. Okay? So this is how we translate this the fact that we had for two given paths in English. Okay? Alright. Good. Now we are in a state to complete the definition that we left in the third lecture, which is about an Olog being a category. We'll complete that definition now, but to complete it, we'll go back to the partly discussed definition in the third lecture. Okay. So definition of Olog as a category and and the introduction of instance function. And the introduction. So I introduce you with the instance function, introduction of instance function. Okay. So this is what we did earlier. So let me recall what we did in the third lecture. We defined Olog as a category, as an abstract category, as a category C. And the instance functor as the functor I from this abstract category C to the category of sets, so that one obtains a set Ix for each object X. So, well, objects are certainly types of the given Olog X in C, and a function I f from Ix to Iy between sets, a function between sets, for each arrow f from X to Y in C. This part we have discussed, okay? Now there are certain features associated with facts that we discussed in this lecture that I'm going to combine with this partial definition of lecture 2, okay? For each fact, so we describe fact as path equivalence, or equation, okay? Right? F1, F2, Fn, so let me detail on this slide, okay? In terms of the diagram we had before, okay? A person has an address and an address is in a city, okay? And there is an arrow going from a person to leave city, okay? So it sort of tells you that for the commutativity of this diagram to hold, we need to have this equation, means that this has followed by easy is the same as leaves, something like that, where the length of the two paths are not the same. Here, for this path, the length is 2, and whereas for this path, the length is simply 1. Okay? So this sort of captures what we have written down here, abstract, mathematical. Alright, so this was declared, so let me raise this example. So this guy, this equation or path equivalence is declared in C. For this path equivalence, an equality of functions should hold, an equality of functions. So how can we convert these aspects into functions? By the action of the instance functor. So instance functor acting on this aspect F1 will be a function, but this now everything will be reversed, meaning that F1 will go to the rightmost end, where F1 was on the leftmost end, and we're going to compose F2 with A, so on, so forth, until we reach all the way up to IFF. Equal, similarly here. So first comes IFM prime, composed all the way up to IF2 prime and followed by IF1. So what happens in our example? Okay? In our example here, I has goes to the right. I is in has to be the same as I is. Okay? So for our example, this tells this part. Okay? The path equivalence amounts to this commutativity of the given of the involved functions. Okay. All right. This was pretty much it. So we are done with the basic notion of an Olog and the key aspects of an Olog, all types, aspects, and facts, and how to think of an Olog as a category. So I had actually plans to discuss database and schema in this lecture 3 and lecture 4, which I could not because time did not permit. I think I'll leave it for some later lectures to cover them up later. But in the next lecture, we'll try to go over the ideas of products, co-products, finite limits and finite pole limits, push forward and pull back and push outs. These ideas we need to understand in the context of the category of sets. So next lecture we'll study products, co-products, their universal properties. Perhaps if time permits, we'll go over the idea of hybrid product and pullback. Thank you very much for attending this